Okay, YouTube, in our last two videos here, we've been exploring sequences of numbers. And in this video, what I want to tell you is this: as we define sequences, that is, we talk about a sub n really is the rule, and there's some rule that goes with our nth term of a sequence here. But we define them differently depending upon different situations. So we define them thusly. One is explicitly. So we say explicitly, these are things like this. I say e.g., for example, this would be a sub n equals 2n plus 1. That's a pretty boring rule. But that would be explicitly defined because I could explicitly tell you, you plug in 1, then I would get 2 times 1 plus 1, which is 3. But explicitly, that's what you get. The other way of doing it is recursively. So we say recursively. I kind of think about this here. It's kind of like meaning again, like, I don't know, I hate to pick a word apart, but we say again, and cursive, I always think of like writing, like writing again, again writing. And it's really weird to think about it this way, but we say a sequence whose terms are defined using the previous term are defined what we call recursively. So basically, we see a very, I guess, a famous sequence here. This is the Fibonacci sequence. We say 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5. We say 3 plus 5, I suppose I would get, 8. And this idea would go on forever and ever, but what you see is that we keep borrowing from the previous term in the sequence to get the next term. So I could say that in general here, my nth term, I'm going to put it this way. I'm going to say a n plus 1. And I'll refer to this as my rule for the Fibonacci sequence here. We say the n plus 1th term. When you talk about a sequence, maybe I'll list this first here. We talk about its first term being a1, and of course its second term is a2, a3, and this goes on for a good time, but we say that an is the nth term. Nth term, of course it is. But we'd say that right after that is really weird. We say is an plus 1. And so when you talk about an plus 1, it's just the term right after an. Or, if I talk about this, we say I guess I wanted to write this here, n plus 2. We say that, like an plus 1. We'd say that this n plus 1 is just the term right before the n plus 2th term. So we say the rule here, I would just say, well, to get the next term, the an plus 1th term, I would take the term right before, which is really what this is, an, and I would just add the term before that together. And it's really kind of a weird thing when we say add the two previous terms, you get the next term. I know that that probably was pretty confusing to you, but let's just put it this way. Whenever you have a sequence where you got to borrow from the last term to get the next term, then that's when we're talking recursively. So what I'll tell you is this. I'm going to put a box around this. And there was a semicolon that I covered up there, but we're going to write this down. We say it's a given term value. You're always going to be given one of the term values, and it doesn't matter which one I give you, but in this case I'm going to give you a1. So as far as our sequence is concerned, we know that the first term in the sequence has a value of 15. So what this is going to say here is ak plus 1 is equal to ak plus 3. So what I'm going to do is I'm going to say that this is the rule here on the left. Rule right there. Don't lose this. That's rule. We say that this k term is the term before the k plus 1th. It's really weird to write. Term. So in other words, if we want to write the first 5 terms of the sequence, and I guess I should read this as it's written, the next 5 terms, because we've already been given the first term here. I say, well, the first term is 15. What this really says is, in order to get the k plus 1th term, or really you could look at it as like the nth term if we define it explicitly, what you do is you take the term right before it, take its value, and you add 3 to it. So I'm going to say, well, ak, in this case, if I wanted to find, say, for instance here, a2. Suppose I write it this way. a2 would be the same as a1 plus 1, where I say this is my k plus 1 right there. So I would say that my term value here would be a1, which is my k value. K value is 1 plus 3. You can see how complicated that would be to write it this way. We say a2 is really equal to a1, which is 15 plus 3. Instead of just saying, just by looking at this, you take the term right before the k plus 1th term and you add 3 to it. So in this case, I'm going to add 3 to my 15. I'm going to get 18. You can see how my next term, okay, my third term, would be my second term plus 3. My second term has a value of 18. So 18 plus 3, we're going to get 21. Our next term here, I suppose my fourth term, we'll go ahead and find my fourth term here. My fourth term, which would really be my a3 plus 1th term, where k is equal to 3. My fourth term would be equal to my third term plus 3. So again, I would add 3, I get 24. I would add 3 to this, I get 27. I add 3 to this, I get 30. And those were the next 5 terms in this recursively defined sequence here. So that is what we mean by a recursively defined sequence. Typically, you're given some first term here like this, and you're given some rule. It says ak plus 1 is equal to maybe 2 times ak or something like that. And you would have to go find the first 5 terms of the sequence. You might try that with this one and see what you come up with. Cheers.